Audio Jungle. Audio Jungle.
Hello everyone, myself Naren Singh Maurya. So guys, today we'll solve GATE 2016 rocket propulsion problem number 46 we have here. So launch vehicle has a main rocket engine with two identical strap-on motors, okay, all of which fire simultaneously during the operation. The main engine delivers a thrust of 6,300, okay, is 6,300 kilonewton with a specific impulse of 428 seconds. Each strap on motor delivers a thrust of 12,000 kilonewton with a specific impulse of 292 second. The acceleration due to gravity is 9.81 meter per second square. The effective combined specific impulse of the vehicle is, okay. Now check in this. We'll draw the diagram so better we can understand. So this is the main engine. Now we'll go for the strap on motors. No? Sometimes it is called strap on pods. Okay. This general diagram I have drawn here so that you can easily understand. Okay. Now, so this is what main, and these are the strap on motor or pods. Okay. So, and both are identical. Both are identical. 1 and 2 both are identical. Okay. Means all the like data will be same for both. The main engine delivers 6,300 kilonewton. So what is the thrust? Main engine it will be 6,000 sorry 6,300 kilonewton. This is the thrust from the main engine, and specific impulse here. What is the specific impulse? It is 428 seconds. Each strap on motor delivers a thrust. So here we are getting thrust. Okay. Strap on motor. STM. It is nothing but 12,000 So obviously both are having the same data. So this side also you will have a thrust. It is 12,000 kilonewton. And a specific impulse it is given ISP 292 second. 292 second. All right. The effective specific impulse of the vehicle is. Now, so what is the impulse or effective impulse? Okay. Basically, impulse is nothing but thrust divided by weight flow rate of the propellant, means thrust divided by weight, means mass flow rate of propellant into g will give the weight. They said effective. Why it is effective? Because both main engine as well as that both identical uh, strap on motors, okay, that will also produce thrust. So the effective thrust now you need to calculate, so that you can, because you are going to calculate effective impulse, you are going to calculate effective impulse, right? So I must write ISP effective, okay. Then here this thrust will be effective divided by mass flow rate of the propellant will be effective into g. So what is the effective thrust? It is thrust produced by the main engine, okay, plus thrust produced by the two identical strap on motor. Yes or no? So I will write F S T M, okay, and both are identical, so multiplied by 2 by the both motors, that thrust will be produced. Yes or no? Two motors are identical, motors are available, okay, that is also called sometimes strap on pod also it is called, but here it is given a strap on motor. So we will write the thrust. What is the main engine thrust? Main engine thrust is nothing but 6,300 into 10 power 3 plus 2 times, what is the motor's thrust? 12,000 kilonewton each. 12,000, okay, 12,000, right? 12,000 kilonewton. So what is the F effective? Effective thrust is nothing but, need to calculate. Wait, it is 6,300 plus 12,000 into 2. Yes or no? Plus 3. So this is nothing but 300 10 power 3 Newton. So this is the effective thrust. Similarly, we need to calculate mass of the propellant effective. Okay. Now, how to calculate mass effective of the propellant? So we'll calculate first mass flow rate of propellant effective will be mass flow rate of the propellant for the main engine plus mass of the propellant, okay, two times mass of the propellant by the STM strap on motors. How to calculate m dot p? M dot p for the main engine is equal to thrust F divided by ISP. This is the formula, okay? Remark. This is the formula you need to remember. Because how this formula is? It's simple. ISP is nothing but F divided by m dot Pg. Yes or no? So you can write this m dot P. All right. So what is the main engine thrust? 6,300 and for 3. ISP for the main engine they have given how much? It is 428. It is 428. We'll calculate this into 9.8 also available. Okay. We'll calculate this 6,300 10 power 3 divided by 428 divided by 9.8. Check. It is nothing but 1502.0 kg per second because it is the mass flow rate m dot p, no? Mass flow rate of the propellant. Similarly, we can calculate mass flow rate of the propellant for the STM strap on motor, that is nothing but thrust, okay, divided by for one motor what is the thrust? 12,000 into 10 power 3. What is the ISP? Let me check. It is 292. How much it is? I will write 12,000 10 to the power 3 divide by 292 divide by 9.8. It is nothing but 4193 kg per second. Yes or no? All right. What is the m dot p for the m dot p effective? It is nothing but m dot p for the main plus m dot p for the STM two times because two motors you have. So what is that total value multiplied by 2 plus 1502.00? This is nothing but 9,888.91 kg per second. This is the m dot p effective. Now we need to calculate ISP effective, right? So what is the ISP effective? It is nothing but thrust effective divided by write all the value. What is the F effective you have calculated? Check. It is 30300. Okay. What is the m dot p effective? It is 9888.91. Okay. So what is the ISP effective? We'll calculate into 9.8. In bracket, need to write 30300 10 to the power 3 divided by this value. So this value I am getting 312.65 second. This is the effective specific impulse. 312.65 second. Okay. I think it is the fill in the blank. Huh? So we'll write here second unit is given. So we'll write 312.65. This is the answer. So hope you all understand this. The steps are very simple. Okay. All right. Now this is the another problem. Okay. Check here. This is the problem number 54. A rocket with total lift-off mass of 10,000 kg, okay, moves vertically upward from rest under a constant gravitational acceleration 9.81 meter per second square. The propellant mass 8,400 kg burns at a constant rate of 12,000 kg per second. If the specific impulse of rocket is 240, neglecting drag, the burnout velocity in meter per second. So they are asking burnout velocity, okay, in meter per second. Now, so we'll write the given data first. Okay, total lift of mass. Total lift of mass also called initial mass. During lifting off, what is the total mass? Called initial mass. So terminology they have changed, but it's initial mass. How much? 10,000 kg. Moves vertically upward from rest under a constant gravitational acceleration. G they have given how much? 9.81 meter per second square. Propellant mass they have given MP. How much? 8,400 kg. Burns at constant rate of 12,000 kg per second. Okay. So that burn rate of the propellant means it is the mass flow rate of propellant. Burn rate means what? It is the mass flow rate of the propellant which is given 1200 kg per second. Okay. If the specific impulse of rocket is ISP, it is 240 second. Okay. Neglecting drag, the burnout velocity we need to calculate burnout velocity is also called incremental velocity or change in velocity, which is nothing but delta U. All right. Now, so for this rocket, Okay. Now, here we have a propellant. So it is going vertically. So better will show the vertical rocket diagrams. It will be more clear because they said from rest it is going vertically upward. Okay. From rest it is going vertically upward. Now, obviously, it is having a propellant. This is the what propellant mass of propellant they have given. Initial mass of the rocket they have given 10,000. Mass of the propellant at 1,400. So initial is nothing but 10,000 kg, and here propellant mass is 8,400 kg. It is given. Now for this rocket, they are asking what is the change in velocity or burnout velocity. So you know that what is the formula for that? It is ISP GLN M naught by MF. What is the MF? Initial mass minus propellant mass. What is the initial mass? 10,000. What is the propellant mass? 8,400. What is the MF? Wait. 10,000 minus 8,400. It is 1,600 kg. Now if I say what is the burnout velocity, so it is nothing but ISP GLN. We can write the value ISP they have given to us how much? 240. 240. 9.8 ln m naught is nothing but 10,000 divided by mf 1,600. What is the value? We'll calculate. Okay. ln into 9.8 into 240. It is 4310.23 meter per second. Okay. This is the burnout velocity, also sometimes called change in velocity after burning of the propellant or during the burning of the propellant. What is the velocity called? Burnout velocity, or you can say it is change in velocity or incremental in velocity. So check, I think MCQ 4310. 4310, it is approximate to this. Yes or no? I'm getting here because 9, I just wait. 9 point, okay, let me, why 4310 then? Okay, we'll do one thing. We'll write 9 point, G is 9 point, wait, G is 9.81. Okay, we'll keep here 9.81. Now we'll check. Multiplied by 10,000 divided by 1,600 ln multiplied by 240 into 9.81. It is 4314, sorry. Because of that, see, if you write 9.81 full, because I had written 9.8 only, for that reason that was variation. Hope you understood now. If I will write 9.81 full, then it is 4314.629, means 0.63. Now check 4314. 4314, exactly this. Hope you understood this solution. Hmm? It's a very simple problem. Only formula if you know, then you can solve this problem. No issue. All right. Hope you understood this. Okay, so guys, keep doing hard work. Thank you all. Thank you so much.